Troubleshooting the 7613. It has a power supply problem this time. Well, I had one before, but it's a new power supply problem now. Previously, the negative 15, plus 15, and plus 5 volts rails would drop out randomly at random times. I would have to use percussive maintenance to fix that issue. So that indicated that there was a loose connection somewhere. The output from the regulator was the only supply that was dropping out. The input wasn't dropping out, so the problem was definitely on this board here. I looked around and looked around and looked around and noticed that some of the voltages on this IC weren't right when the power supply dropped out. I took this as a faulty TI or Texas Instruments IC socket, which is here. I thought this was faulty because these sockets are notorious for failing all the time. So I decided to replace it with a machined socket. So you see those round ones, those are machined sockets, and I put that. So now that issue should be solved. However, it seems that I damaged something while doing that modification. Because now, the 5 volt supply is double the voltage it's supposed to be. It's at 10 volts. That's not correct. In fact, I can show you that. Very briefly, let's find the 5 volt. And if I can keep that there somehow, that should be good. You'll read that this says 5 volts or 10 volts. And that's measuring the 5 volt rail. That is not normal. That's double the voltage it's supposed to be. The other rails measure perfectly fine. I didn't keep it on that long because this thing has 10 ohm capacitors, and I don't want a 10 ohm capacitor on the 5 volt rail to short and then have another trouble of finding that. So far there doesn't seem to be any shorts on the 5 volt rail. It's just that this regulator is outputting double the voltage. Here's the schematic for the 5 volt regulator. Here we have 8 volts coming in from the 5 volts. But this should be around 11.5 volts at Q988. I'm reading 10 volts, and a 1.5 volt drop again across here should be around typical if this was failing somehow. So I'm going to check Q988, except that I believe it's one of those huge BJTs in the TO3 packages here. I think that's what it is, but so I will check that later actually. So let's analyze this. This point over here at pin 4 should be 4.9 volts, but I am getting 10 volts. And it's outputting 10 volts, and this connects here through a 0.1 ohm resistor and a 240 ohm resistor, so the voltages here should be fairly similar. That makes sense. Supply voltage here is 11.5 volts. So either something is wrong with this transistor, or what's driving this transistor here is being turned on more than it should, and is driving this transistor high to turn on and bringing in almost all of the 10 volts here. And this goes here and goes here, this goes here. So driver transistor, and this is another driver for it. So this is essentially kind of a Darlington pair. And then this comes here, and this is the 5 volt sense. Our issue may be here. I may have damaged that chip, and the 5 volt sense here is not working properly. Let's measure the voltage at, let's see, are there any voltage measurements here? Just 0.2. So pin 12 should be negative 0.02. And the anode of CR981 should be 7.3 volts. Let's measure the anode of CR981. Where's CR981? Here's CR980. CR981 should be close by. There it is. CR981. Let me highlight that so I don't miss it again. That is right above U973, which is this thing here. U973 is just a transistor array. It's not anything particularly special. So let's see here. Right above here. Anode of CR981 should be 7.3 volts. Let's measure that, shall we? Let's get an alligator clip. Find CR981. These capacitors I added before. Wow, this is dim. CR981. Here. Oh, why is this turning? There we go. Right over here is the anode of CR981. Oh, that's not attaching properly. Maybe other side. Yeah, much better. Now I just connect this to my DMM probe. Turn it on and see if we see 7.3 volts. No, that's 13 volts. That is much too high. Let's see if that, oh, I'll take that later. Let's see if that tells us anything useful. So if the voltage here is high, we might have, no, this goes this way, so this transistor could be breaking down and then bring this 15 volt through here from the collector to the base, but this is an NPN, so diodes go this way, but again, it could be a faulty transistor and this could be breaking down. But let's hope it's not, because this is an IC, whereas this is an IC that we don't want to have be faulty. So let's go here, and this is much too high, so could be coming in from here, but unlikely. So yeah, our 10 volts coming through here, going through here, but that's lower than this voltage being found here, so anywhere else we could see an issue. Is this our reference diode? Maybe it's supposed to be a zener, but it's not symbolized as a zener. I'll come back to this. Okay, so I thought about it a little bit, and so here's how this basically works, it seems. So if the voltage here is too high, which is the sense feedback that comes in from here, which connects directly from 5 volts and then goes right back to the power supply, so that's just sensing it. So there should be 5 volts coming here, 5 volts come in here, no, 5 volts come in here, it should be here, and then some voltage would be here, which would turn this transistor on and pull down the voltage here a little bit, so that this, and this won't turn on as much. If this voltage is too high, that's what would happen. This transistor would pull down the voltage here, would decrease by a substantial amount. This transistor would turn on less, turn on less, turn on less, and thus providing less voltage, which means there's going to be less voltage here. And then that's how it just regulates. The issue is that here, there's 10 volts here. This transistor should be on, locked, and then the voltage from 50 volts here should be 7.3 volts. But no, the voltage here is actually 13 volts. This could mean that this transistor is breaking down and allowing 15 volts to get in here, and thus through here as well, and then turning this transistor on too much. Or this transistor is not turning on enough because it's faulty, and then it's not pulling this resistor down enough to bring the voltage here low enough to 7.3 volts. This could be an issue with perhaps this resistor not conducting properly. This resistor here conducting too much and bringing this voltage down too much and not allowing enough voltage here at pin 12 to get it to conduct properly. I actually measured the voltage here and it was around 4.3. It says it should be 0.02. But if the voltage here is 4.3, then current should flow through the base into the emitter. And this should turn on, right? I'm starting to suspect this is faulty. Maybe the IC is faulty. Okay, so I measured the voltage at the emitter of U973E and it's 8 volts. So if we have 4 volts here and then 8 volts here, current isn't going to flow here. In fact, it'll want to flow this way, but this is a diode junction that only goes this way. So no current's going to flow here, which means this transistor's not going to turn on enough. So that tracks with this being very high. Why is this high here? Why is it 8 volts here? It should be negative 0.6. Maybe it's because, no, that's only 5 volts. No, wait, the 5 volts comes from here. So perhaps this transistor is bad, as in that it's always on, but it really shouldn't be on because this is a negative. This is 0 volts here. So if this is a negative voltage, current should flow here like this. It should be negative. It should be around, yeah, it should be a negative voltage here. Around negative 20 volts, I guess. Yeah, it should be around negative 20 volts at this point. Let's check that actually. It's CR973, but so if this is 8 volts, there shouldn't be any current flowing through here because this is a lower potential than here. Is this transistor shorted? Let me check the anode of CR973. CR973. CR988, CR980, and CR970, or CR973. CR973 right over here. It has a T on it, which means it has an alternate location. Let's hope that's not for us. So it's right above. So it's right over there, top left corner of that. There it is. Right there. Let me measure that. So it is actually negative 32 volts. So if we have negative 32 volts here, that must mean current will want to flow through here like this, but there's 8 volts here. The issue is here somewhere. Let me check the voltage at pin 11. I'll be back. Okay, so I have some really good progress. So I bodged a 500 kilo ohm resistor from pin 6, or the collector of this transistor, to ground. So I can adjust that potentiometer and drop this voltage down to turn off this and this and this. If this works, then everything here is working and something down here is not working. So I did that and it works. So this multimeter measures the voltage from this point, or this point, same point, to ground, from this point to ground. And then this multimeter measures the 5 volt rail output. And if I turn it on, I already adjusted the resistor. I am getting 5 volts output. I am getting 7.25 volts at where 7.3 volts should be. And where's the potentiometer? Over there. This potentiometer that I just adjusted is giving me 5 volts. So now if I power on the scope regularly, put everything accordingly, the scope works just fine. Nope, no issues there. Oh, the readout died. That's a normal thing that happens to this scope that I also need to fix. Nothing wrong here. I can adjust the vertical position, horizontal position, turn on magnification. Yeah, it's just some power supply issues. So if I put this into right where there's no compartment, can't change anything there. It seems to work pretty well. Let's see if I can connect a signal through here. Well, that's mains frequency. I want to see this signal. Oh, well, you saw that, right? Let's see. Well, there's our square wave. It's around 4 volts peak to peak, which is exactly the voltage that should be output. So the scope works. The issue is that there's a power supply issue. And for some reason, well, I know the reason why this transistor isn't turning on is because there's 8 volts here and 4 volts here. So if we only get like a maximum of 5 volts from here, or 10 volts, it's going to get dropped here to around, say, 4 volts maximum. And then this is 8 volts here. There's going to be a positive voltage here compared to here. So there's no current's going to flow through this transistor, which means it's not going to pull this down. So why is there 8 volts here? Why 8 volts here? It could be, yeah, maybe this transistor shorted, so it's bringing that 5 volts there. We can check that actually with the scope running now. If I put let's measure pin 13 and see if we get 5 volts here. Okay, let's do that. Alright, so I have it hooked up to ground through this BNC connector to there. Let's measure pin 13, where is it? And there it is. We're getting 5 volts. More. Oopsies. Is this still working? My probe slipped. Okay, it's working still. Well, you saw we're getting 5 volts there. That's not right. I bodged the resistor correctly. It should be negative 0.67. We're getting almost the exact same voltage out here that's going to here. So I think this transistor is shorted. Yeah, that makes sense. This transistor is shorted. Except the issue is that this is the IC. I can't desolder a transistor from that IC because it's literally inside the wafer chip. So unless I find a suitable transistor array chip, I don't think I'm going to be able to completely fix it. I'll just have to keep my bodged potentiometer through there. So I get 5 volts here. Can't be from here because this is so negative. Yeah, I actually think this transistor is just shorted. Yeah, that makes sense. What I could try is removing the IC and just putting in a transistor, an actual transistor from a cheap transistor kit. let's see if that rectifies the issue. But let's also see if this transistor is being used anywhere else. I highly doubt it, but you can never know. So if A, B, C, D, E. Yeah, no, it's not. It's all for this 5-volt rail. Alright, let's replace this. So that's 10. So it's 11, 9, and 10. So 9, we need a transistor with pin 1 as its base. Do I have any? I'm like, yeah, I do. And then pin 2 is going to be its emitter. No, that's its collector though. What if I just bend the leads of some transistors to make it fit? Yeah, I think I can do that. Let's do it. So I have the transistor set up accordingly. It is going to be base, emitter, and collector. So from left to right, base, emitter, and collector. If we ignore this bottom part and come up here, it's emitter, base, collector. But now if we go here, it's now base, emitter, collector. And now I just gotta pop it in that while lifting pins 11, 8, and 9. No, I mean 11, 9, and 10. Alright, let's do that. So this is our transistor array. We have 14, 13, 12, 11. Oh, 11. So 14, 13, 12, 11. Right here in the middle is 11. We have it's magnetic. And then we have 10, 9, and 8. 9. So these 3 pins need to be bent up and replaced with this transistor. Let's see if that works. Okay, so I found it very difficult to use an IC and also put in transistors into the same socket at the same time. So I decided to just replace the entire transistor array with just transistors. I wonder why Tech used a transistor array though. Was it for temperature matching? Or was it just because it was cheaper to use one IC instead of 5 transistors? One would never know. Unless we ask Tektronix, of course, but it doesn't really matter at this point. I should probably disconnect everything that isn't. Alright. So the moment I press this power button, this should only go up to 5 volts. That seems right. And it's working. I'm not using the potentiometer. It's showing me 5 volts. It works. It's just a bad transistor array. At least I fixed it. I just need to find a new transistor array, of course. I think I damaged while I was trying to replace that IC. I mean the socket. Well, that's a successful repair, I'd say. Seems to be working just fine. Let's see if I can do that square wave again. Yep. There's a square wave. And I'm reading right on 5 volts. So it appears that the LM30, 45, 46, and 86 series transistor arrays are equivalent to this one here. Let's look. We have emitter connected together at pin 3. Emitters collected. Oh, wait. Yeah, wait a minute. Oh, no, I see. Yeah. Emitters connected together at pin 3. Collector at pin 1. Collector at pin 1. Base at pin 2. Base at pin 2. Base at pin 4. Emitter at pin 3. Emitter at pin 3. Base at pin 4, and then this weird thing that goes from 6, 7, and 8, and then we get this weird thing that goes from 6, 7, and 8. So this is the one I need. That's good. Here's a little bonus. If I turn this on, you'll notice that these lamps are on. Typically that is not possible for a 7600 series mainframe, but these lamps are on, these push button lamps. How is this so? Well, that's because I did a modification. If you look down there, that is a 5-volt regulator. Now let me turn this off. It takes in 9 volts from the supply up here through that connector and goes into the input of this 5-volt regulator. It's grounded through the tab, and then the output ground is through the pin, and the output positive as well. So if I disconnect this orange connector here, that's the output. This connector here is the 5-volt output from that regulator. And you'll notice that if I plug this back in, and then turn it on now, you'll notice the lamps don't light up. But now if I remove this orange connector and plug this thing back in, like so, the lamps will now light up. This is not balanced. Anyways, that's the end. Bye bye.